Firstly, I would like to thank the organizers for organizing this and having me over. Um, I'll start with a recommendation. Please do not have such good lunch. It is very difficult to stay up after that, especially the gulab jamuns. I saw people having at least 3 gulab jamuns each. It's going to be a very difficult job for me to keep everyone awake here now. So thanks for making my life more difficult, but please, next time, don't do that. As introduced earlier, I'm Nimay Mehta. I work as a global solution architect. And the topic for today is IoT, AI, and blockchain. I'll tell you a funny story to start with. So when I told one of my colleagues, not my colleagues, one of my non-technical friends that I'm going to speak, I'm thinking of speaking, and this is my topic, he said, "Kitna show off karega yaar, now just stop." He said, I told him, no, it's not show off, it's a real thing. And he's like, I don't understand any of it, and all you're doing is just trying to talk about every technology possible. Hopefully, throughout the next 30 minutes, you'll realize it's not just show off. There is a particular customer problem that I want to try to solve. As I said earlier, and a comment which I made was, as solution architects, we only think about technology. But over the last few years, I've realized that actually solving customer problems is much, much more important than the technology that sits behind it. Once you have a customer problem that you want to solve, then there is all the technology in the world to solve it. So hopefully in the next 30 minutes, I can give an overview of how we can use these 3 technologies together. Hopefully it ignites some ideas in everyone's mind. So the idea, I want to use supply chain as an example, but this could be used across a lot of industries. So hopefully you'll have more ideas towards the end of the session. Right, so I wanted to start with a few questions, and I know we've done the exercise, but hopefully this will reiterate that exercise. So the first question I had was, how many people here have shopped online? All right, almost 100%. Okay, the people who didn't, I'm sure have gone off to sleep. So the second question I had was, how many people have returned a product that they received online? Wow, that's a huge majority. I did not expect that. And how many people did not want to shop online after having returned a product? Right, okay. So the problem that I wanted to solve started from that image on the left-hand side there. So this was an image that came in the newspaper, and where a person ordered an iPhone for 60 grand, and all he received was that Surf Excel. So I thought it was a one-off issue, and I absolutely laughed it off. But then since then, I've spoken to a few people in the industry, in the supply chain, consumer supply chain, and I realized that, oh my God, it was a much bigger issue than I thought. So 5% of the phones that get delivered don't have the phone in them. They either have potatoes or they have soap in them. I don't know how people afford potatoes because it's become so expensive now. So I guess they went down the soap route after that. But the point being, global statistics say that 1 in 4 products that are ordered online are returned. And when you actually go to buy a shop, only about 7% of them get returned. Now, this is costing industries like Flipkart and Amazon a huge amount. It's almost in the lines of 100 billion per year, which is an absolutely huge amount, because what's happening is that they are having to get the product back and ship another product to themselves, and they are incurring the cost of that. The same applies even in B2B. So one of the clients that I worked with, Airbus, they reckon that they return 30% of the products that they receive before manufacture or before doing the assembly of the aeroplanes itself, which is huge, because they say that because of that, they usually have a delay of at least 1 month in assembling an aeroplane. And all of that goes into the cost of the aeroplane, right? And the reasons they gave was that some of the times they get rusted, some of the times they are mishandled, and some of the times they don't get what they expected, right? So there seems to be a huge problem in the supply chain where products are being delivered, but customers are not receiving what they asked for, or they're not being delivered in the fashion that they were supposed to be. And that's the problem I think I want to try to resolve using these 3 technologies that I spoke about earlier. So again, I think I slept off when I was writing this slide. That's why the last line just said cost of returns and doesn't say anything. I'm surprised no one pointed it out. That means I'm still sure everyone is sleeping. So yeah, the cost of returns was about 100 billion, as I said. So hopefully using the 3 technologies, we can actually bring it together. Now, when I was doing some research around getting an analogy to show how we can use IoT and blockchain. I came across this interesting article which was about how IoT originated in the first place. So there was this brand manager, an associate brand manager at Procter & Gamble. His name was Kevin Ashton, and he realized that actually, although it was really difficult to create products that customers love, what was even more difficult is to get those products to the customers in the first place. And this was back in 1999. So there was no online shopping, and the internet had just become a thing at that time. And he said that the biggest problem was he didn't know which products were in which shops and how many products were put in every single shop, etc. And he said that I wish there was a way to actually put sensors in this. And he termed the word Internet of Things. That's from there it originated. One of the things I found particular about it was the name that he termed. It is Internet of Things, and not something like Java or like something named behind a coffee bean or something named behind an island. That shows that it was not a tech person who actually started it. It was someone from business. I'm sure if it was to a tech person, it would have been called Kor Mangla or Baner or Pimple Saudagar, for a matter of fact, because all they can think of is the thing that's outside and like, oh, there's an oak tree there, let's call it oak. So that's the origination of Internet of Things. And I thought that if in the supply chain, we can actually put a nervous system to the supply chain, right? So I want to give a bit of jargon about biology because I know I did it in 11th and 12th, although I hated it. So the nervous system is made up of two things. One is the peripheral nervous system, and the second is the central nervous system. The peripheral nervous system is nothing but all the sensors in our body, so our skin, basically. All our skin is doing is it's sensing different modes, and it's sending that to the brain, and then the brain decides what needs to be done, right? So what if we could add this to the supply chain? What if we could have sensors and we could have a brain and a secure way to communicate with each other? If we could do that, then we should hopefully be able to solve the problem of supply chain, because it can't be more complicated than human beings itself. So that's where that's where it all started, and I said, right, okay, let's look at sensors first. A bit of statistics about sensors. When I read this, I was quite surprised. So Gartner predicts that there are currently about 8.4 billion IoT devices as per 2017, and it's meant to grow, right? By 2020, the number is going to go up to 20 billion. Why does that matter? It matters in many ways. So when we say devices, this doesn't mean our smartwatches and doesn't mean our smartphones in our pockets. These are physical things out in the world that have sensors and that are now speaking to either us or speaking to each other. And the amount of data these devices are generating is absolutely incredible. So to give an example, like a car that goes out, an autonomous car that goes out and drives for 8 hours, collects about 16 terabytes of data. By 2025, it is predicted that the amount of data that will come out of these devices will be more than the amount of data that is generated across any system as of today. It's going to be about 180 trillion gigabytes of data. So there's a huge amount of data that is coming in. Either we are going to have to find smart ways to store this data, or we are going to have data centers all over the city, and no human beings are going to be living in the city anymore. So those are just some stats about the devices itself. So, right, okay, if we put the devices out into the supply chain, we can get some data. What next, right? So that's where AI comes into the picture. So a few people ask me whenever I speak about AI that these sensors have been there since the last 20, 30 years. What has changed? Why is IoT such an important term? Why has Industry 4.0 said that IoT is going to be the thing that changes everything? I think there are a couple of things. One is previously, we weren't able to process this amount of data that we have today. So with big data, with analytics, etc., we can make some meaningful information out of this data. And secondly, we weren't able to predict what will happen using this data, right? So imagine a washing machine in your house. that is connected to the Internet of Things, and it realizes that you are running off the washing powder and it automatically orders it for yourself. Actually, don't imagine all of this exists today. But we couldn't do all of these things because we couldn't connect our devices to the internet to make it to do things. We couldn't understand the data that was being populated out of these IoT devices. That's where AI plays a huge role. We want to make our system smarter. We want to put a brain into all these sensors, into all the data that is coming from these sensors. And that's why AI. And the last bit, blockchain. I'm not using the word blockchain because it is the sexiest term around, and if you have blockchain on your resume, everyone will come and speak to you about it. But there is a particular reason why in IoT, blockchain is going to change quite a lot of things. It does not mean it will happen in every single industry, but it will happen in certain use cases. As alluded in the talk in the morning, that don't use any technology for just everywhere because you have to use it. Use it if there is a reason to do it. The reason, I mean, just to give a brief overview on what blockchain is for people who don't know, it's a distributed ledger system, which is nothing but distributed database. All the data is stored between all the people who are part of the blockchain. And the way the data is stored is not like a traditional database. It is stored in blocks, and these blocks are chained together using cryptography, okay? If all of this sounds complicated, just think of this as a ledger which is highly encrypted, okay? If you think of this, when usually we say blockchain, a lot of people think of Bitcoin, which is great, but Bitcoin is not the only use case of blockchain. In fact, Bitcoin is the reason why a lot of other industries are now getting disrupted because of the technology that it uses behind. So why blockchain and how will it help in IoT? So blockchain have a few characteristics that are really important that will make a huge difference to IoT in general, right? The first one is the immutable nature of the data. So you cannot change the data once you write into those blocks. If you want to change the data, you have to create a new block at the end of it. This means that you cannot cheat. We as Indians love to cheat, and like when we try to sell this to governments, etc., they're like, oh, no, this is going to kill us because it's going to end corruption for us. But you cannot change any data that is there. There's full auditability of every single data in the blockchain. The second bit is smart contracts. These are just agreements that are enforced. So for example, if you want to enforce a particular car to be returned to servicing when something in the car goes wrong, you can enforce this automatically. Usually you have to write a lot of business rules, you have to write a lot of custom code to actually implement these business rules. With blockchain, these smart contracts, when you write data into the blockchain, the smart contract can be validated on its own. I won't go through everything, but obviously the distributed ledger nature, meaning everyone has the data. That means that actually it makes it almost impossible to actually hack the data. Bitcoin has been around for the last 10 years. A lot of people think that Bitcoin has been hacked and all these cryptocurrencies have been hacked. But actually, the data has never been hacked. What has been hacked is the hash code that is required to access the data. No one has ever been able to hack the data in the database itself. So as far as you keep your keys secure, that's fine. So these characteristics mean that actually we can bring in AI, we can bring in blockchain to actually make IoT much more exciting. We can make it much more secure. So there's a piece of work that's happening where devices will communicate with each other using blockchain. Today, it is predicted that by 2020, 40% of the hacks will be on IoT devices. Which is huge. Imagine your car being hacked and being driven into a human being somewhere, as you would have seen in Fast and Furious. All this is happening today. It's just that we don't see it in day-to-day life. So security being the key reason, then building of trust. When there are multiple parties involved, one thing that is lacking using all the technologies we have today is trust, right? Trust is usually a contract that we sign with each other, and then we eventually break the contract. So blockchain allows you, because of the immutable nature of data, it allows you to build that trust within all the organizations. And I'll give you an example later on. Cost reduction, as I said earlier, if we can predict when machines can fail, we can predict when your car needs servicing, it's going to cause less damage, and hence you'll be able to reduce the cost that is required. And finally, accelerated data exchanges. One of the biggest problems in IoT is how do you exchange the data between the devices? If we have 180 trillion gigabytes of data that is going to be generated from these devices, we are never going to have a cloud. Even AWS will not be able to store all this data. So we're going to have to do something about it. And what we will be doing is making the devices smarter, allowing the devices to understand the data, allowing them to run those algorithms on the devices itself and make a decision, rather than having to stream it to the cloud or be having to store it somewhere. Okay? So this slide was just to say that blockchain is not for every single use case, although a lot of people think that let's just use blockchain everywhere. We'll get VC, we'll get funding, we'll get everything. There are certain use cases where blockchain will excel. So for example, where there are multiple actors involved, you want to make sure that there's trust between the actors. Where there's auditability required. So because the data in the blockchain is immutable, it means that it is completely auditable. You can send it to your legal, your compliance people, and they will be able to audit the data that's in there. And wherever reconciliation is required between multiple devices. So how will all this work? So there are two architecture patterns that are out there, where either the asset or the gateway or the device itself is speaking to the cloud, and that is then eventually speaking to blockchain. So all your AI models, all your blockchain is being stored after the data is coming into the cloud. Now, this is the use case that we're seeing the most at this moment in time, and this is being used predominantly for compliance, for examples like customs, etc. The second example, which is device directly talking to a blockchain. So this is where you'd run AI on the device itself, and you would run the node of the blockchain on the device. Now, there are certain challenges with this approach. The devices today don't have the resources to run a full blockchain. They cannot act as a node. They do not have the resources to run a full AI model. So there are a lot of technological advancements happening in these spaces. There's a light Ethereum that is being developed to run light nodes on resources. There's light TensorFlow, which is out in the market to run algorithms on your devices itself. But this is still evolving. So the second use case is where we're seeing people trying to experiment, trying to find ways to basically store the data, trying to find ways to get devices to talk to each other using blockchain. But it's not out in the industry just yet. But it is going to be the reason why blockchain needs to come into IoT, because it'll ensure security, it will ensure that the data cannot be hacked, and that is the future that we want to get to. So I've not spoken about supply chain until now. The reason being, this is the only slide that I have on supply chain. What I want to do with this example is basically try to explain how it will all work, right? How in supply chain we can involve IoT, how we can involve blockchain. So what you see here is a manufacturing plant. So just imagine that you've created an order in one of your systems like Salesforce, which is then sent to the manufacturing plant. When you create that order, what will happen is a smart contract will be created within the blockchain. A new node will be added within the blockchain. That smart contract will have all the business rules regarding that product that needs to be shipped, right? So in the example of you receiving a phone, you want to make sure that it is not opened until it reaches the customer. You want to make sure that it does not fall. If it falls, then there's likely that there's going to be damage to it. Or even if it does fall, there is only a certain limit that we wanted, a certain impact that it can actually handle. So those business rules will be set up when you actually create the order. Those will create a smart contract, which will then be sent to the manufacturing plant. The manufacturing plant will package that product with whatever sensors that are required. So in this case, a light ambient sensor and a pressure sensor, which is then shipped. Now, the reason why people receive soaps instead of phones is because in a supply chain, at least in India, there are at least 6 parties involved in shipping that product to the customer. Okay, so you've got a person who's shipping it to the nearest airport, then you have a person who's actually shipping it through the flight, then it reaches the airport, then it goes to your local warehouse. From there, it goes to a warehouse that is closer to your house, and then there is the last mile delivery, right? And the problem that Flipkart and Amazon have in India today is they don't know at what point in the entire supply chain the product is being adulterated. So now that we have the sensors, we'll basically be able to, whilst the product is moving, it'll be streaming all the data into the blockchain. Now there will be instances where the devices will not have connectivity itself, right? So the data will be stored locally in the meantime, and when it reaches the next point of connectivity, that data will then be streamed into the blockchain and stored in the blockchain. This way, throughout the life cycle, you can almost create a story for every single product. A story that says it originated in Bangalore and now it has reached Pune via these 5 parties. This will be extremely useful information both for the customer and for the supply chain partners itself, right? So me as Flipkart, I'll be able to know who damaged my product, at what point it got damaged. Me as a customer, I'll know where the product is through the journey, and hopefully there is a future where a customer does not receive a soap. So what we can actually do through this process is, as soon as we realize that the product is adulterated, let's not ship it to the customer. Let's create another order in a system. Let's send another product to the customer whilst we figure out what is happening. One of the use cases, or one of the stats that when I was reading, was that about 40% of the customers who return a product don't ever shop online using the same website. Now, in the UK or in the US, there's only Amazon, so you don't have an option, and that's the only thing you have. But in India, you've got options. We've got options. So that's where Flipkart and Amazon are losing customers. One, they're losing to the brick and mortar shops on the street, but more importantly, they're losing because customers are not receiving what they actually want. And hopefully there is a future where no customer will get a product that is already damaged. I wanted to end with this. I think I've spoken about most of these things throughout my talk. So how will all these 3 technologies come together, and how can it help businesses and customers? So it'll help businesses save money. Another example in the supply chain is that now imagine when this product is getting shipped. Whenever there are international shipments, about 30% of the cost of international shipments goes to actually doing the paperwork that is required for it to pass through customs, okay? And that's incredible. That's 30% of the transportation cost. What if we could store all that in the blockchain? We could get customs onto the blockchain, and all the customs had to do was make sure that the data on the blockchain was secure. Yes, fine, let's pass the data through. There's no paperwork required. The customs can actually trust this. And again, this is not futuristic. The Singapore port tried to actually do a pilot with this, where they shipped a shipment from China to Singapore, and they used blockchain, and they've deemed it as extremely successful, and they're trying to make it into production. So the onus is going to be on the governments or on the people who are going to enforce these implementations to make sure that all industries try to implement the same solution, right? So because of that, there are a lot of consortiums that are coming together. So supply chain is not a problem that only Flipkart has or only Amazon has, right? It is across industries. If everyone starts creating their own solutions, using blockchain becomes almost pointless, because then it's being centralized by that company. So you ideally want something that's a platform which everyone can use and store data in. And that is what these consortiums are trying to do. You can make money with this. So now that you have all this data, etc., you want to share it with third parties. You want third parties to be able to access this data and create additional services on it. The traditional way of sharing data does not always work. You have to give access to your APIs to a third party, which can then get hacked, and then it causes all kinds of issues, right? All the banks in the UK are facing this issue today. So now that the data is in a blockchain, you can create a trusted partner in the blockchain who can be able to read that data. And lastly, but most importantly, you'll be a differentiator in the market, right? So customers should be at the middle of everything that you do. And if customers are unhappy, then your business is not going to work. You won't realize it now, you will realize it 10 years down the line. And you realize that because people were getting soaps back in their day, Flip got shut. And it's very difficult to track back to that, right? But you want to make sure that you're providing your customers the best experience. And if a customer never receives a product that is adulterated or never receives a product that has been damaged, even if I get a product one day later because it got damaged midway through, I'm fine with it as far as I get the product. At this moment in time, I get a product, then I have to go and return it, and then I have to wait for the next shipment to come. And by then, you've lost the customer, right? So hopefully, this has given you an idea of what these three technologies can do together. This was, again, just one example of what these three technologies can do together. I think there's a point that I wanted to make, which was people are using technology on its own, right? So people are experimenting with blockchain and AI, all of it. But people have forgot that convergence of technologies can create an experience that's far better than just using that technology on its own. And hopefully that brings you a lot of ideas. If you have any ideas, come speak to me later, or I'm happy to take questions now.
Thank you. Is it possible to shed some light that who are the current gatekeepers of this technology, first? And second is that what, in your opinion, as a technologist, we should do that the industry and government embraces this technology in future?
Sure. I think it's a really good question. Who are the gatekeepers? As of today, there are no gatekeepers. Everyone's trying to do their own bit. As I said in my this talk earlier, that there are certain consortiums, which are open source consortiums that are trying to implement this. What they're doing is they're trying to get companies like Maersk and DHL and all onboarded. If they can get majority of the supply chain partners into the consortium, then it can become the norm. So that to your first question, actually, there is no one at this moment in time. And I don't think there should be one because that beats the purpose of blockchain, right? Blockchain was invented to remove the banks, remove the control from the banks in the first place. If there is a central body that now has control over all of this, it almost beats the purpose. The second question, what do we do to get companies to embrace this? So what we are doing at the moment, and what I think has worked really well is we're still allowing companies to experiment this as pilots, right? Get your hands dirty. Let's implement a small pilot where we can do this. Whatever we build for you is not what is going to be in production, because you're going to have to actually sign up to a consortium or sign up to a wider blockchain eventually, right? So don't be stupid thinking that you will create your own blockchain. It might work for certain use cases, but it won't solve your end-to-end problem. If you want to solve your end-to-end problem, there are these things that are happening right now. But do pilots so that you understand the technology. You understand that when this technology comes, you have the people that are trained in it. Because if it comes all of a sudden as a rule or as a regulation, at that time you'll have to run around and you won't find the people that you need. So start doing pilots now. Yeah.
So I understand that the technology is still in infancy and research is happening around. So looking at the things, the Internet of Things, the connected devices and all that, the data is growing at a humongous speed. And understanding the blockchain case study in such a scenario where the replication and consensus needs to happen in real time, what research is being done so that speed of transaction, real-time transaction improves?
Okay. So, I understand where this question comes from, right? It comes from the fact that Bitcoin takes about 10 minutes to do a consensus on a single block at the moment. Look at the size of Bitcoin today. It's got over 1 trillion transactions, okay? In your IoT world, which is localized, you're never going to reach that limit, number one, right? So I'm not trying to run away from the question, but number one, the same problem that Bitcoin has will never come here because Bitcoin is something that's global, and what's happening over there is it was using cryptography methods which weren't ideal. Now there are new ones in the market that claim are better, but no one has reached the size of Bitcoin to really be able to test that. Then in IoT, what is happening? So there are a couple of things. We are trying to do experimentations where we don't store the entire payload of the data in the blockchain itself. Okay. What we're doing is we're only storing some metadata in the blockchain. The actual data is being stored in traditional databases. And then that metadata is stored in that blockchain. So if that metadata gets hacked, your previous data becomes unusable anymore. So those are the experiments that are happening at the moment. There are other ways that people are trying to modify the blockchain for it to work for IoT. So this is the references one. The second way that they're trying to do is not store all the data on every single device, right? So device needs local data only till a certain point in time. It does not need all the historical data. So let's store the historical data on a on-premise or on a cloud blockchain. Let's store only the recent data on the blockchain in the device. So that way you're going to store less data on the devices, and which hopefully should solve the problem of resources on the devices.
That answers, thanks.
When you say we are saving the data in a different format, again, we are coming back to the distributed architecture as well as the centralized architecture in terms of while saving the data.
Yeah.
So when we save the metadata in my local machine and your other data on other machines, so don't you think that again it will increase the transaction, and when you have the humongous IoT and other devices will connected,
Right.
it will create a problem data transaction, it will slow down the process?
Not really. So, I mean, the way we are trying to store the other data on another machine or on the cloud or whatever is using clear business rules, right? If you want to access data beyond a week, for argument's sake, you need to go to that database. If you want to access data within the week, go and speak to the devices. It's as simple as that. So you have to change the way the orchestration works where you are accessing the data from, number one. Number two, I don't think personally that this has matured yet. I don't think personally that way will solve the problem. I am a proponent of storing just metadata rather than storing the entire data on the devices. But there are different people and there are different pros and cons. We don't think that there'll be a single way or a single technology that will come that'll solve problems across all industries. Different industries will have different use cases, and they might have to use a slightly different pattern. And that's why I said that the device-to-device blockchain communication is still evolving. Where we are seeing a lot of traction is where people are just storing it in the cloud or storing it in their local blockchain. Right. Yeah. So again, that's a question that you get normally whenever you speak about IoT, right? You've put sensors on the streets, and now you're capturing all my information. So where is it all going? This is another reason why you use blockchain. So blockchain is something that cannot be accessed or cannot be hacked, as I said earlier. The traditional approaches of storing data mean that it'll be stored in a database which has a username and a password. And that username and a password is very easy to hack, or is relatively easy to hack, to get access to, which is what is happening everywhere today. Whereas in a blockchain, if you want to hack a blockchain, you have to hack all the blocks that come before it to actually reach the data that you actually want, right? So every block is hashed as compared to the previous block, and you have to hack literally the cryptography across the entire blockchain, which makes it almost impossible to break it. Which is another reason why I said that as from a security perspective, this resolves some of the privacy issues. Now, do I want to be captured everywhere I go, and do I want my photos all over the newspaper tomorrow morning if I do something wrong? Absolutely not. But is there a benefit that I get out of it? If I get better security, or if I get better traffic management or whatever, then maybe I might think about it.
Yeah, hi. Okay, so my question was related to blockchain as use case for insurance. So I just wanted to know if you've come across any issues like this. So, well, basically a blockchain, when you relate it to insurance, you would think smart contracts, and you would have to execute a smart contract based on some calamity or some insurance incident that would happen. So, for example, if there is a crop insurance, maybe the rains haven't come and the census sense that particular thing, and then the payout happens to the farmers, or in case of accidents, similar something could happen. So my question is like, it's sometimes you could pretty much, I mean, you can't hack the blockchain like you said, but you could actually hack the sensors to act as if the rain hasn't come. And so I just want to know if you've come across any things like this. And of course, when you have blockchain, the payout would happen in terms of money, but blockchain would use, in my opinion, only cryptocurrency, which you would have to convert to normal fiat currencies. And so that would kind of beat the purpose.
Okay, yep. So if I take that question as two parts, there are a lot of insurance companies. So I've predominantly worked with clients in the UK. There are a lot of insurance companies in the UK that are exactly doing that. So what they're doing is they are giving customers sensors or devices that need to be put in the cars. So over there, the way it works is you get a car insurance, and the car insurance is based on the age of customer. Okay. If you are between 80 to 25, you get the most expensive insurance because you're likely to be a rash driver. And if you're between 25 to 40, you get the cheapest. And if you're 40 and above, you get a decent price. Now, this does not work every time, right? So what insurance companies have started realizing is they need to have liquid insurance policies. So depending on the way you're actually driving, to create an insurance policy based on that. So what they've started to do is they've started to give these sensors out, which are stored in the cars, and basically that is capturing your speed, that is capturing information like proximity to the next car, etc. And based on that, it's creating a profile. And based on that, it's changing your insurance policy as you go along. Okay, so if you break a certain rule, and it's storing all this into a blockchain. So there are smart contracts in the blockchain. Depending on the data pattern that comes back, it matches to a particular smart contract, and that is how you make the payment. Whether it gets hacked, in general, as I said earlier, that security is going to be the biggest concern. There are ways you can secure it, but it's not 100% foolproof at this moment in time. That's why people are trying to use cryptography on the devices itself rather than a username password. The traditional way of how IoT works today is you have a username password or a certificate which is as good as a username password that speaks out to your data. Okay, and it's easy to hack that username password. That's why people are trying to experiment with running mathematical cryptography formulas that change on the fly, that secure the communication between the devices and the cloud. And that's one part of it. The second part of your question, so what happens when people try to change it, right? So if it's raining, for example, in your example, and if I just pour water onto it, what happens? You can't change people's nature. We as Indians love doing jugaad, and we'll try to do jugaad till whenever we can. We try to take data from other sources too. So in the example of rain, we try to take weather data in that localized region. When we take speed, we don't only take the speed information from the car that you are in, but also in the car that's next to you, if they have the insurance policy, right? So we're trying to collect data from multiple sources to actually make sure that the data that we are getting is right. It may be that it can eventually get hacked, or it can eventually be manipulated from the source itself, but then that's up to human beings, right? We have to be the change if we want to be the change. It goes back to that. Whenever I see this whole traffic problem, we keep complaining the government doesn't do this, but how do we drive, right? Like it's almost, we are causing the issue. So I think a part of it is how we handle it, but there are different ways in which we are trying to resolve that.
This last question.
I have a slightly off the beat question, so it's going off tangent. But I want to know if you have read any research material, because there's so much IoT which you talked about and billions and as per the survey. So there's going to be a lot of radiation generated. A lot of that or generated out from cars, houses, and so on and so forth. Have you read any research on how it's going to affect the human body? If you don't know the answer, it's okay. You can pass it ahead.
Yeah, so I'll answer part of it and then I'll leave it to that. So this whole thing that mobile phones next to us emit radiations and they cause cancer, etc. there are two sides of the same thing, right? There is this side of people who say it 100% happens. The side of this people who say that it doesn't happen. No one has been able to prove it. Wi-Fi in general does not cause radiations that harm us. Otherwise, we'll be dead by now. There's Wi-Fi everywhere we go, right? And most of these devices are trying to speak in Wi-Fi. They're trying to speak in lower protocols than Wi-Fi, okay? So there are lower protocols like MQTT, etc., which it's trying to speak in. And those are much, much lighter than the general Wi-Fi itself, right? Or than HTTPS or than the other protocols that you have outside. So I don't think it's going to be such a big issue. If it is, we'll be dead in the next 5 years anyway, so we won't know. Because there's just so much radiation out in the world.
All right then.
All right, thank you.
Thank you.